Yes, under these topics permutation and combination we are mainly focusing in combination today. And the combination is a group or selection which can be formed by taking some or all of a number of objects irrespective of the order or their arrangement is a combination. Combination means the selection of the object, and the number of selection that can be from n different object taken r at a time is given by cnr or ncr, or defined as cnr equal n factorial by n minus r factorial times r factorial. Somehow we have discussed this in the first period also, first part also. Then this example also we have discussed. A boy puts hand into a bag which contains three marbles of different color, red, blue, and green, and bring out of two marbles. How many different results are possible? One, red and blue, green and red, and green and blue. Three different results. It can also be solved by using the formula C and R, where n is 3 and R is 2. Three numbers but taking two at a time. It goes like this: total number of marbles 4, selection number of marbles 2, and using formula of C and R, n factorial by n minus r factorial times r factorial, required number of possible different result is C 3 2 3 factorial by 3 minus 2 times 2 factorial. That is three different ways which is shown in the figure as well. Now we have to discuss about the formula, dear students. One theorem is that the total number of combination of the set of n objects taken r at a time is given by C and R equal n factorial by n minus r factorial times r factorial. HSEB question. Okay, you have to prove this. Firstly, let me show you some. Okay, I will prove this, then I will explain this, then I will make you clear by another example as well. Okay, let us consider any one of combination is C and R is a combination. This single combination consists of r different objects. These r different objects can be arranged among themselves in r factorial different ways. The corresponding to each one combination, there are r factorial permutations. So for C and R combination, there are r factorial times C and R permutations. But the total number of permutation of such set n objects taken r at a time is P and R. Now, P and R is C and R times r factorials, and dividing this P and R means n factorial by n minus r factorial, and C and R times r factorial. That's why this is n factorial n minus r factorial times r factorials, which proves the given theorems. So one question, I will make it clear, dear students, from the real example as well. This is theoretical proof, and the condition is, the point is, or the concept is given here. One, you have to consider one concept, dear students, that is, I will write here, there are only one combination of an object. Here are only one combination of n objects, but for the same n objects the number of permutation is n factorial. But the same number of n objects, there are n factorial permutation. Now, three letters A, B, and C is given. Three letters A, B, and C is given. Then the combination is, selection is A, B, C, three at a time. A, BC, only one. But in permutation, it may be ABC, BAC, ABC, BAC, CAB, and BCA, and CBA, and ACB. 1, 2, 3, 4, 5, 6. 6 permutation. One combination. It means it can be arranged in a single way, but here 3 factorial ways, 3 at a time. तीनटे एक पटक लिने. That is 3 times 2 times 1 equal to 6 ways. But here only one selection is this. Out of 3, ABC, BCA, ACB, all are same, considering the same in combination, but in permutation, that is in 3 factorial ways. So CNR that we have proved is CNR R factorial times CNR is PNR. So R factorial times CNR equal n factorial by n minus R factorial. Therefore CNR equal n factorial by n minus R factorial times R factorial. In this way we prove the theorem. Now the second part is, dear students, the number of combination of n things taken r at a time is equal to the number of combination of n things taken n minus r at a time. Symbolically, C and R equal to C n minus r. We will prove this later one. First, remember, it is very important formula. C and R equal to C n minus r. And note number 2, this is first one note. And second number note, C and R, if C and R equal to C n comma r dash, then either r plus r dash is n or r equal to r dash. We can use in binomial also. We have to use this in binomial also in the next lesson. So let's check and recall this. C n r equal to C n comma r factorial. If given, then r and r dash equal to n or r equal to r dash. There are two conditions. And note number 3, dear students, C n r plus C n comma r minus 1 equal to C n plus 1 comma r. These 3 theorems we can prove now theoretically. Then by exact definition, examples, or we can study or we can solve them by using the exact examples. So by that example also you can verify, but you have to remember all 3 formulae or the note, or what to say, important point. The theorem is the number of combination of n things taken r at a time is equal to the number of combination of n things taken n minus r at a time. Okay, we have to prove C n r equal C n minus r. We have to prove this. First of all, from RHS we can take C n minus r equal using formula. Yes, we know that C n r equal n factorial by n minus r factorial times I factorial r factorial. We prove this. So C n minus r means n factorial over n minus r factorial times n minus r factorials equal n factorial over n minus n plus r factorial by n minus r factorials equal n factorial by this can be cancelled Then first I write this n minus r factorial times r factorial, which means CNR equal to LHS. Therefore, our conclusion is, dear students, CNR equal CNR n minus r. And by the real example also we can try. We can try by using real example. Suppose C5 equal C 5 minus 3 is 2. Uh, it can be 5 factorial y 5 minus 3 factorial times 3 factorial equal 5 factorial y 5 minus 2 factorial times 2 factorials. Then it is 5 factorial 5 minus 3 is 2 factorial times 3 factorial. Here also 5 factorial by this difference is 3 factorial times 2 factorial. That's why CNR equal to CN minus R. The condition, second condition is, we have to prove CNR equal CNR dash if then R equal R dash or R plus R dash equal to N. Solution, dear students. Since CNR equal CNR dash or CNR equal CN, this is N minus R dash. In first what we prove, CNR equal CN N minus R, we prove this in first condition. So here I have applied the condition from here. Yes, CN N minus R dash. Yeah. Then CNR equal to CN N minus R dash. So R equal N minus R dash. Therefore R plus R dash equal to N. Also CNR equal CNR dash, R equal to R dash. That implies R is equal to R dash. Hence R equal to R dash or R plus R dash equal to N. We have to apply this condition in binomial, and while problem solving also we have to apply this condition. This is also important part. Moving to third part. CNR plus CNR minus 1 equal CN plus 1 comma R. We have to prove this. CNR plus CN comma R minus 1 equals CN plus 1 comma R. So prove this theorem. Sorry. We know CNR plus CNR minus 1 equal, we have given this. CNR is n factorial by n minus r factorial times r factorial plus CNR minus 1 means n factorial by n minus r minus 1 factorial times r minus 1 factorial. First part is this. Then yeah, n factorial by n minus r factorial times r factorial plus n factorial y. What is this? N minus r plus 1. N minus r plus 1 factorial times r minus 1 factorial. Then the next step, dear students, we have to take common. Yes, r minus 1 is this. So r means what? Again, one more step. N factorial by n minus r factorial times r factorial means r times r minus 1 factorial plus n factorial over n minus r plus 1 times n minus r factorial minus 1 minus 1 and 1 cancel, that is n minus r plus 1 minus 1, it can be cancelled. R minus 1 is step. 5 factorial means 5 times 4 factorial, like that. 1 less factorial, that number times 1 less factorial. That's why n minus r plus 1 factorial is n minus r plus 1 times n minus r factorial, because 1 will reduce, times r minus 1 factorial. After this, what is common in both n factorial, n minus r factorial, and r minus 1 factorial? This common. Let me change the color. So n factorial over this is n minus r factorial, and this is r minus 1 factorial. Then here remaining 1 over r, only r, here remaining 1 r, plus here remaining 1 over n minus r plus 1. This and these terms are remaining in that part. Then, dear students, after this step we have to apply n factorial over n minus r factorial times r minus r factorial times, here we should take common, that is LCM, n minus r plus 1, here product is n minus r plus 1 plus r times 1 is r, equal, this can be cancelled, n factorial over n minus r factorial times r minus 1 factorial times, here remaining n plus 1 over, in denominator, r times n minus r plus 1 only. This is not the factorial. Then, dear students, next part is, let me again change the color. Then the next part is, dear students, n plus 1 times n factorial, it like this, like this, 6 factorial times 7, it is 7 factorial, I know, your n plus 1, and this is n, 6 factorial times 7 is 7 factorial, that's why it can be written as n plus 1 factorial. On the denominator, n factorial times n plus 1 is n plus 1 factorials, like this I have shown here. And similarly r times r minus 1 factorial this r times r minus 1 factorial is r factorial, that is r factorial, like 6 times 6 minus 1 is 5 factorial is 6 factorial, that's why r times r minus 1 factorial is r factorial, times now n minus r plus 1 times n minus r factorial, that is n minus r plus 1 less is this, means n minus r plus 1 factorial, यो र यो पनि तपाईको n minus r plus 1 factorial by. Yeah. Now dear students, we are at the end of the proof. यो दुईटाको कम्बाइन एउटा आयो, यो दुईटाको कम्बाइन एउटा रिलेसन आयो, यो दुईटाको कम्बाइन एउटा रिलेसन आयो. सो n plus 1 factorial by n plus 1 minus r factorial from this term times r factorial, we got the result. So n factorial by n minus r factorial times r factorial is c n plus 1 r equal to RHS. Proved. In this way we can prove this property. Now moving to the further step, dear students, I have prepared. We have proved this theorem. You can study, and it is very important part, that is restricted combination. You have to apply this also. It is very important. First number is the number of combination of n things taken are at a time in which k is a particular object always occurs is c n minus k comma r minus k times. Yes, combination. We have to subtract k from both n and r. If k particular always occurs, if the number of combination n objects taken are at a time in which particular object never occur, in that case we have to subtract the value of n from n only, not from r. It is BIMP concept. We have to apply in question number 3 or question number 17, like that. Anyway, it is important concept. Always occur, we have to subtract from both. Never occur, we have to subtract from n only to find the combination. Now let's summarize what we have discussed. We have discussed this formula: CNR is n factorial n minus r factorial time r factorial. CNN is 1, that you know. CNN is 1. CNR is CNR. If CNR equal to CNR1, then r equal to Rn, or r plus r1 equal to n, that we use dash or 1, that is the symbol. And CNR minus 1 plus CNR, you can interchange their position, that will be CN plus 1 times r. This is we have discussed. Now dear students, I will show you some question. I will make you clear, and the remaining question I will solve like previous way. Okay dear students, first we have given a question. The question is, if C18R equal to C18R plus 2, find R and C18R. This is a question. So in this case, dear students, C18R equals C18R plus 1. Using that condition number 2, we have to equate R equal to R plus 1. It is not possible, as R does not equal to R plus 1. So next condition is what? R plus 2 equal to 18. So 2R equals 16. Therefore R equal to 8. And now you can find C18R equal to what? That easily you can find this solution. So using that second condition, if CNR equal to CNR dash, then either R equal to R dash or R plus R dash equal to N. Using this condition, we have solved this question. Now C18 easily you can find. There is no doubt for that. Okay, now moving to the next question, dear students. Second part is, the question is, if C15 3R equal to C15R plus 6, find R. So either 3R equal to R plus 6. In this case, R equal to 3. Yeah. Or in this case, R equal to 9 by 4. It is impossible. It won't be fractional form or in negative number. R not in fraction and not in negative. You have to remember this. R always in integer form. So not negative and then not the fraction. So second condition is impossible here. First condition, from the first condition we find R equal to 3 to solve this question. From here what you learn is neither in fraction nor in negative form the R will exist. And next question, dear students, the question is, yeah, a committee of 5 people is to be from 12 men and 8 women, consisting 3 men and 2 women. How many such committees are possible? Hey, it is very interesting question, but not so difficult. 5 people, committee of 5 people, 12 men. Men, how many? 12. How many women? Women are 8. Yes, and we have to form the committee of 5 people, consisting 3 men. Here 3 men and 2 women. 3 + 2 = 5. We have to form. So from here and from here we have to find. So number of men 12, women 8. Number of people in this committee is 5. That 3 men and 2 women. That's here I have shown. So 3 men can be chosen from 12 men. See 12 3 ways. Similarly, 2 women can be chosen from 8 women, that is C8 2 ways, and total number of committee is C12 3 times C8 2, that is 6160 ways. You have to find that C12 3 equal 12 factorial over 12 minus 3 factorial times 3 factorial equal 12 times 11 times 10 times 9 factorial. 12 minus 3 is also 9 factorial times 3 into 2 into 1. It can be cancelled. 3 2 are 6, 2 are 12. So 11 2 are 22, 10 are 220. The value will be this. Similarly, you can find the value of this in expanded way. In this way, you have to show these steps. Here I have written in shortcut using calculator. I have written, but you need to show this process, because this is a not very difficult job. So I have done in shortcut way to make you clear, dear students. That's why that something equals 6160 where is our required answer. From 12 men and 8 women, consisting 3 men and 2 women, a committee need to be formed. Then we can form the committee in this way.